Okay, so I'm thinking that we might need a few tips on these acids since I was kind of giving some people problems today. I'm going to give you these 4 examples here of some nomenclature that you might get. We're going to try and write some names and then I'll go through how to go the other way. The first thing you want to look for whenever you have hydrogen. Hydrogen is the first thing we're looking for an acid. The second thing that we have to have is it's got to be aqueous, because aqueous means it's dissolved in water, and when this stuff dissolves in water, what you end up with is H plus ions that float around, which is really just a free proton. That's what you're going to consider an acid probably until about second or third year university. So that's what we're going to go with. I'm just going to get rid of that. That's how you identify if it's an acid. Now this one here, I'm going to change color. Let's go with blue. This one here doesn't have aqueous. So it's got hydrogen, but it doesn't have aqueous. So what I do is I look at that and I say, okay, is this a non-metal with a metal, or a metal with a, sorry, is this a non-metal and a non-metal, or a metal with a non-metal? And I said hydrogen's always best to be assumed to be a non-metal first. So in this case, if I look at it and go non-metal and non-metal, that's a binary compound. It just keeps its name, hydrogen, and gets the ending IDE for the second one. So that would be hydrogen chloride. Now, if we consider that a non-metal, probably the best name to give that would be hydrogen monochloride. That's probably what I'd be looking for on a test or a quiz. In actual fact, we probably just call it hydrogen chloride. And typically this is a gas. It's a pretty nasty gas. It gets in your lungs. It's pretty bad. So that's how I would name that. This one looks very similar, except we do have, this is horrible, but AQ. That tells me that that gas was now dissolved in water. So I do have H+. I only have Cl. I don't have any O's or anything with it, so it's not an oxyacid. So that one is going to be a hydro something ic acid. In this case, the something is chlorine, so this would be hydrochloric acid. Now these ones both have hydrogen and aqueous, so they're going to be some form of acid. So I'm just going to write acid down first because I know that they are an acid. What I then have to notice is they do have oxygen. These are polyatomic ions, and you just have to recognize that the hydrogen in the AQ is acid. This part's polyatomic. In this case, we have some form of polyatomic ion. This one is called sulfate. And this one, if I look it up, is nitrate. Now, the only way to do that is to look it up on your polyatomic ions chart. Then you have to figure, how do I change the name of the polyatomic ion over here to the name of the acid? Well, 8s become X. So this should be, if I get eraser on here, eraser, this should become sulfic acid, and this should become nitric acid. So let's go back to blue, nitric, sulfic. That's what we would get. Now this one here is a little bit different, just in the fact that we don't actually call it sulfic acid. Coming up with sulfic acid, if you did that, then that's okay. It makes sense. You followed the rules. This is one of those ones we just have to learn that we actually call it sulfuric acid based on the sulfate ion. So that's how we would come up with our acid names there. We'll do one more just for those us icks. ClO3 is chlorate. We'll do ClO2. It's got to be aqueous. This is 1 minus, so I have an H plus. So if I gave you HClO2, you would have to recognize that we have H in aqueous, so that's some form of acid. I have to look up ClO2. It might be there, which is chlorite. If it's not, you would find chlorate is ClO3. 1 down from an 8 is an ITE. It's an ite. And all we do to name that acid is it's a chlorite becomes a chlorus. Ite becomes us. And so this becomes chlorus. acid. None of these ones here have hydro because they're not binary. They have oxygens, they're oxyacids. The hydrogen, the hydrochloric acid, this is only for binaries. So an example for that could be that one. If I have aqueous H2S, I have H and AQ, so that's got to be an acid. As soon as I see, where's my red? As soon as I see an H and AQ, I know that that's an acid. Maybe I'll switch it this way to black. But this has only got sulfur, so it's a hydro something ic acid. And this is S, so it's sulfur. Again, you could see why it would be called sulfic acid, but we don't. We always use the UR, sulfuric. So hydrosulfuric acid is H2S. Sulfuric acid is H2SO4.